And see, these kinds of observation led to the idea of attention as a bit of a filter. The idea that as all this information hits us, and in fact produces what Gibson would call proximal stimulation, so gets transduced inside our brain into electrochemical signals, um, somehow there's a filter that allows for the information that we care about to make it through, and the information that we don't care about, the information that we do not want to attend, to be rejected and to be discarded. And so this is the idea of selective attention, the idea of paying attention to one thing while ignoring others. And so the theories that emerged from these observations and from more experiments, which we'll discuss in just a moment, envisions something of this sort. A lot of sensory input is hitting your sensory organs all the time. And somehow there's a filter, there's a screen that allows for not everything to go through, only the stuff that we want to attend to. So the way in which selective attention has been long studied in psychology is by using a task known as dichotic listening. Now, the idea in dichotic listening, and you see it pictured right here, is that if you were the participant, you would have headphones, and the messages, the sounds, what is being played through the two ears is different. Your task is the following. Listen to what comes in to this ear and totally ignore what's coming in the other ear. In fact, in order to ensure that you do what I say, not only you have to listen to what's coming in this ear, you also have to shadow it, meaning as this comes in real time, you have to repeat every word that you hear. And you have to try to do this as accurately as possible. So really the name of the game is to listen very, very carefully to what's coming into the ear that you want to attend to. So listen very carefully to the message you want to attend to and repeat it, and avoid any intrusion from the other side. So you really want to try to filter out anything from this side, and you really want to pay great attention to this. And see, this is a wonderful way of allowing us to study not only, how well can we focus on something, but also of the stuff that you're not attending to, how much of that does it actually make it in through your cognitive system, inside your mind. Now, what is interesting is that, of course, participants were good at telling you what was the message that they attended to, the message that they were repeating. If you later ask them about that message, they can typically recount what was in there. But they could surprisingly tell very little about what's coming in to the other side. In fact, if you ask them, participants could tell you some things, but usually it was really low-level features of the unattended message. For example, if suddenly it switched from a human voice to clicks or noise or tones, people could tell you that. If the frequency of the voice, if the properties of the voice changed, as in the average change from a perhaps lower male voice to a perhaps higher, on average, female voice, or that sort of auditory acoustic change, then they could tell you that. Interestingly, however, participants really couldn't tell you anything about the syntax of the message. For example, if you'd ask them, in the ear that you were not attending to, was it actual sentences that you were hearing, or was it just random words? Subjects can't tell you that. So that level of information apparently didn't make it through. In fact, they couldn't even realize that if the language half a way through switched from English to German. That's just how well the unattended message was being suppressed. And of course, finally, they really couldn't tell you anything about the contents of the message. There was no trace of having any recollection of what was the meaning and what was being said in the unattended channel. In fact, in 1959, Moray, again, with using this particular approach, found that really you could even just repeat the same word in the unattended ear 30 times, and participants wouldn't be any better at guessing or recalling or reporting what was in the ear that they didn't attend to. Now, these observations that people fail to notice a lot of the information if they're not specifically attending to it, like inattentional blindness and like change blindness, and more importantly, the results from these dichotic listening experiments gave rise to the theoretical approaches trying to model selective attention a bit like a filter, filtering incoming information and deciding what to keep and what not to keep. Now, the first model of this sort is known as the Broadbent filter model, also known as the early filter model or early selection model. And the idea is that information comes in from the world, and there's some of it you might want to attend, and some of it you might not want to attend to. And all the information that hits your sensory organs gets transduced into your brain. And so all of the information gets briefly held inside these sensory stores, often referred to as sensory buffers. And this is only a brief period of time. Then from here, information gets fed to a filter, and the job of the filter is to decide what to keep and what not to keep. And the filter in this model employs, based on simple physical properties, so things such as the voice, the frequency, the pitch. So based on these very simple and very low-level physical properties, it decides which message to attend to and which message to reject. And this, of course, consistently with the results we just saw from the dichotic experiments, the dichotic listening experiments. Now, the information that is unattended at this point gets discarded, gets rejected, whereas the attended information then gets sent on for further processing. And I should say Broadbent called this part a detector, something that detects the meanings. But a more sort of contemporary reinterpretation, which also allows to highlight certain features of this, would essentially view at this point a processing for meaning. So the information that is kept, you process that further, including you process its meaning, so the semantics, the content of the message. And then from there, the information gets fed to sort of your short-term memory. Essentially, you become aware of this information. You can employ and make use and report this information, and you can use it for, say, responding or creating some behavioral response. Now, there are two key aspects to this model. The first is that the filter that decides what to keep and what not to keep, as I said, does so on the basis of very low-level physical properties. Now, this, as I said, is consistent with the dichotic experiment, with the results from the dichotic experiments. So this means the second important feature, that the unattended information never gets passed on to perceptual and meaning analysis, meaning the contents of what is in the unattended channel never get processed. So in other words, you never really get to know what was said and what are the semantic contents, what was the message inside the unattended ear. Of course, conversely, what is in the attended ear gets, after it passes through the filter, gets fully elaborated. And so, as I was saying, one very important consequence, one very important implication of this model is that no trace of the meaning of the unattended message ever makes it through the filter. So your brain never gets to know, never gets to assign meaning to the unattended channel. But see, then there are a number of observations that don't seem to fit as well with this idea. And one you might be familiar with it's typically referred to as the cocktail party effect, and it might have happened to you in several other circumstances. Maybe you're somewhere, you're talking to someone, or you're paying attention to something, and then suddenly the person behind you, and you are not listening to them, you are talking to someone else, says your name, and that just, you hear that. You hear that, you turn around, or maybe they say the name of your best friend, and you hear it. It just, that somehow, even though you are not attending to it, right? In the sense, you are focusing on the conversation with whoever you were talking to, um, and you were trying to block out, presumably, um, stimuli from other conversations. So you were trying to filter out that information. Somehow, even though you were trying to block out everything else, your name or your best friend's name, or sort of, important words like fire, those make it right into our attention. So, but this is, if indeed the early filter model, the early selection model were right, you would never get to know that somebody said your name, because that stimulus never got, because you were not attending to it, never got processed for meaning. So you never got to know that, according to that model, you never got to know that somebody said your name. You just got to know that somebody was speaking in a certain voice, with a certain frequency, with a certain pitch, but you never get to know that the contents of what they said, according to the early selection model, the contents of what they said were your name. Now, the cocktail party effect is just an observation, but you can recreate, in certain senses, this in the lab, again, using a dichotic listening approach. So this is the case of Morey in 1959, who did show that some information makes it through. So this is, again, the exact same dichotic listening experiment. So you are listening supposedly to what's coming in through this ear, and you are shadowing it. Yet, if in the other ear, suddenly you were to, you were to hear your own name, you would suddenly start listening to that ear, and you would follow, you would start shadowing that ear. So in the example here, you're probably shadowing what is being said here. There is a very great opportunity here. But then suddenly you hear your name, John, in the other ear. Now switch to this ear and repeat, ball, sky, jump. And sure enough, as a participant, you will start shadowing what's being said here. But how did that happen? According to the early selection model, you never got to, this is the unattended ear. You never got to know that what is in there is your own name. And yet, people almost always detected their name when said in the unattended ear. Another wonderful demonstration from the year after was that if you actually give a meaningful narrative and you play it in such a manner that words that follow each other alternate ears, then people will switch from one ear to the other. For example, perhaps here you're shadowing this, you're shadowing the right ear, so you're supposed to say dear, 6, Jane. However, if in the other ear you hear, with the good timing, the word aunt, then people typically say, dear Aunt Jane. So in this sense, again, there's something that is making it through that has to be more than just the sound. Because how did the if everything from the sound, from above, just hearing sounds, gets supposedly ditched because of the filter, how did the subject ever get to know that in this ear there was the word aunt? Okay. And yet, typically, people will do this. They will do dear Aunt Jane, and sort of, if there's something relevant in the other ear, or something that would follow what you expect, then people, apparently that message still makes it through. And so it is this kind of intrusions from the unattended channel, from the unattended ear into your conscious awareness, that really felt completely incompatible with the early selection theory. I mean, if the early selection theory was right, none of what is in the unattended ear should ever make it through to the point that you know what is the contents of what is being said. Yet, very clearly, in the cocktail party effect and its demonstration in the lab, in those two dichotic listening experiments, clearly shows that more than just the sound makes it into our minds. So it cannot be that the filter is early, right there, and filtering out information only based on low-level acoustic features, because very clearly some semantic information is making it through. And so the question now is, okay, but then the stuff that you're not listening to, so just how much of that gets processed? Because if you remember, people don't seem to be able to report what is in there from a meaning point of view. So just how much information actually does make it through? And see, if you think of it, the problem is that anything that reaches our ear, anything that reaches our senses, um, gets transduced from whatever medium is carrying it into electrochemical systems, into electrochemical signals. We can't do anything about that. Okay? Your ear, your cochlea, your basal membrane inside the cochlea, the organ that transduces pressure waves into electrochemical signal, it doesn't have a mechanism for attention and for filtering. So that information is definitely making it in. And then somewhere in there, right, at what point does the information get filtered out?